So this next section on modeling just continues our focus of quadratics, especially looking at quadratic equations that are in vertex form. And an equation in vertex form, or quadratic equation in vertex form, is always in this has this sort of structure to it. And as you can probably guess, it's called vertex form because you can kind of tell where the vertex is by looking at it. And if you're unfamiliar with this, the best way of working with this is to look at some examples. And so I have a quadratic function here, f of x. It's in standard form right now. I want to write it in vertex form, and I want to use that to visualize the graph of the function. So to put this in vertex form, the process is called completing the square. And the first thing we have to look at is realizing this coefficient of 3 in front of the x squared. We need to factor that out. And so, but only factored out of the first two terms. The constant term of plus 2, which does tell me the y-intercept, I don't really need to do much with it with completing the square. So my first step here is I'm going to rewrite this where I've factored the 3 out of the first two terms. So I have x squared minus 10x. I'm going to give myself some space. I'm going to shove this plus 2 over here somewhere. The key is our goal is now to make this a perfect square. And a perfect square trinomial has 3 terms in which the last term and the first term must both be perfect squares. To make this a perfect square, it's always 2 steps. We look at the coefficient of our middle term, which is now negative 10 since I took a factor of 3 out. We need to divide that by 2, which is negative 5, and then square it, which is positive 25. So I know there must be a 25 right here for this to be a perfect square. Now keep in mind at this point, I've just changed this function. I've added a plus 25 where there wasn't one before. And so I can't just change the function without balancing it out. So I need to balance out this plus 25. Which I can do quite quickly as long as I realize I actually did more than just add 25 to this function. I really added 25 times 3. So as soon as I put that plus 25 there, I really added 75 to this function, which I can only do if I immediately balance it out. And how do I balance it out? Just over here, right, minus 75. And now what I have is in different form from what I was given originally, but it is equivalent. I basically added 75, 25 times 3, and then so I right away subtract 75, so it all balances out. And now that part you see highlighted is a perfect square, which means I can write it as just its factors, which must be the same factor twice. In this case, x minus 5 all squared. And whereas this part here, my constants, I can now combine like terms. Negative 75 plus 2 is negative 73. And what I have now is an equation in vertex form. And from this equation, I can see a lot about the behavior of this quadratic function. I can see the vertex is at positive 5, negative 73. I can tell that it's opening up, or it's concave up, because that's a positive number. If that 3 there was negative, it would be opening down or concave down. And let me sketch this now. So to make a quick sketch, I'm going to just show my xy axes. The vertex, 5, negative 73, I'm going to show it, roughly down here somewhere. So 5, negative 73. Keep in mind it's opening up, but as well, I could tell from the original equation I was given that plus 2, that constant, is my y-intercept. We saw that in the last lesson. So a y-intercept of 2, well, if I look at the scale of my y-axis, that's going to be really, really close to the origin here. So I'll just kind of put it basically right here. So I know it must go through 2. And so I'll sketch my quadratic function. All right, so what I sketched, that is y equals f of x. That's my sketch. And keep in mind, I could see all the main details of this function when it was in vertex form. And I'll just go to Desmos quickly to confirm that I haven't made any mistakes. And keep in mind, you're always able to graph things in a graphing device. So here is on just a basic zoom setting. I'll zoom out a bit, and I'll now compress my y-axis a bit to make it a bit nicer. There we go. And so notice there's my vertex, 5, negative 73. It looks like my sketch. All good. All right. So I also now want to talk about how from the factors of a quadratic function you can see the x-intercepts. And so I have a new function, g of x, and I want to factor it to determine its x-intercepts. I want to complete the square to time the vertex, and from that I should have lots of details rather quickly about this quadratic function. And so first, looking at g of x, if I want to factor it, I don't have to factor that negative out from it, but if I do, it'll make my life easier. So I'm going to factor that negative out of everything, or it's like factoring a -1 out of everything. And so this is now negative or -1 times x squared minus 2x minus 15. And this here is a pretty standard trinomial. I just need to think about two values that multiply to -15 and add to -2. And I have my factors, and those two integers are -5 and +3. And don't forget I have a factor of -1 in the front as well. And so now that I factored g of x, I can see the x-intercepts. The x-intercepts I can see from here. The x-intercepts must be at +5 and -3. So +5 and -3. And it's not, I don't have time to go into too many details about this, and ideally this sounds familiar. But for example, with +5, the reason I need to change the sign is that if I put a +5 right there, that factor becomes 5 take away 5, which is 0. 0 times everything else is 0. And that's what an x-intercept is. An x-intercept is a value that goes in that makes the output equal to 0. So I just need to find the opposites there. That's it. I now know the x-intercepts of this function. I also know the y-intercept, +15, but I can't see the vertex from this form. So now I'll complete the square again. So over here, I'll write this out again, but this time I want to start the process of completing the square, in which that negative or -1 I want to factor out, but this time just to the first two terms. So I have x squared minus 2x. And that +15, I'll just kind of put over here for a while. All right, and like before, my goal is to make this a perfect square. And so to make that a perfect square, to find what that third term in the trinomial must be, I must take the coefficient of -2, I must chop that in half, and then square it. And so I get -1 squared, which is +1. So if I put a +1 here, what you see highlighted is now a perfect square. I need to balance out the change I just made. So that +1 really is being multiplied by -1. So although I put down a +1, I really had a net change of -1 to this function. I really subtracted 1 from this function when I put that in there because it's being multiplied by -1. So to make it balance out, I think what's the opposite of -1? Well, +1. And now, while my equation looks messier, perhaps, it is all equivalent to what we had before. And now it comes together quite nicely. So now to put in vertex form, I have negative or -1. This factors to x minus 1 squared. And over here I have my constant of +16. And again, this is now in vertex form. And again, it's not wrong to have a 1 there. And so I can now see that the vertex is at 1, 16. All right, so put all this together. I have my x-intercepts, I have my y-intercept. Again, I've highlighted that in green. I have my vertex. I have a lot of information about this quadratic function, so I should be able to make a pretty accurate graph quite quickly. So the vertex 1, 16, I'll estimate, I'll kind of show it right here. 1, 16, not 1, 6. There we go. It is opening down, or it's concave down because of that negative there, which I can see in many different places. And so it's going to be going like this in general, but I want a bit more detail. The y-intercept, remember I showed that earlier, that's at 15, so I can show that quite nicely. I know it must go through that point there. I'll make it in blue. The x-intercepts were at -3 and 5, so one of them must be here at -3. One of them must be, let's say, over here at 5. And just like that, I have 5 points to my quadratic function, so I'm going to sketch it out. Yeah, it's a little bit messy, but such is life. And there we go. And from my sketch, keep in mind again, that vertex. I could see in vertex form, the x-intercepts I could tell from my factors. And my y-intercept I could see from the constant term in standard form. And although I'm done, I'll again confirm by going to Desmos, showing this, go to a basic zoom setting. And notice there's my vertex up there at 1, 16. I can see the y-intercept and the x-intercepts are correct. So we're all good. All right, last question. I have a parabola, and I know the x-intercepts, and I know another point. So from that, I want to find the equation of the quadratic function and express it in standard form. So first, let me realize if there are x-intercepts here and here, then I know this function must have factors of x. Take away 1 times x take away 4. Those must be factors. However, I can't assume that's everything, because to be a quadratic function, it could still have some sort of coefficient at the front here, some sort of a value. There can't be another x. If I'm multiplying by another x, then I get a cubic function. At some points, x to the power of 3. So I know it has factors of x minus 1 times x minus 4. But like I said, I don't know if that's it. And it's probably not it. Otherwise, that would be too easy. But that's it. I know most of my equation. My equation can now be of the form some number times x minus 1 times x minus 4. So now the question is, what's that number? If that is like a 1, then that's it. But like I said, it's probably not 1. However, I know my function also goes through 6 comma negative 12, which means I know when x is 6, y is negative 12. And so I can use that, and I can substitute that into my equation and use that to algebraically figure out a. So instead of y equals all of this, I can say negative 12 equals a times. Instead of x minus 1, I can say 6 minus 1. Instead of x minus 4, I can say 6 minus 4. And I know this has to be true, because if it goes to the point 6 comma negative 12, then I know when x is 6, y must equal negative 12. Now I can solve this quite nicely. I get negative 12 over here. I get a times 5 times 2. So I have negative 12 equals 10a. Divide both sides by 10. A must be, well, in decimal form, negative 1.2. And so now I can put my equation together. I can go back up here. If the tablet lets me do what I want to do. No, it wants to keep fighting with me. There we go. I can write this now as y equals negative 1.2 times x minus 1 times x minus 4. Keep in mind, just to confirm, I'll confirm on a graphing device here that that's correct. And so if I go here, let me turn that off and turn this on. So this is the equation that I just figured out. If I kind of look at it, keep in mind, all I was told the x-intercepts, I can see those are right. I was also told it goes through 6 comma negative 12. And if I look at this function here, when x gets to 6, yeah, there we go. That's correct. And so I know my equation is correct. All that's left is to put this in standard form. And so there's various ways of doing it. I would first just distribute, expand, and simplify the factors. So I have negative 1.2, and here I have x squared minus 5x plus 4. Just, again, expanding and simplifying that. And then I'm going to distribute the negative 1.2. So I have negative 1.2x squared. I have plus 6x. And I have negative 4.8. And that's in standard form. And while I'm at it, since I put it in standard form, if we did that correctly, there should be a y-intercept at negative 4.8. And let me go back to Desmos. And phew, I'm right. Good. I didn't feel like making any changes. All right, so hopefully that sounds familiar. Again, in a lot of other math courses, they tend to go into a lot of detail about quadratics. Otherwise, here's a quick overview of things.